In 2013, Explorer 1 accomplished a noteworthy achievement by turning into the first human-made object to enter interstellar space. This noteworthy accomplishment happened 36 years after its flight from Earth. The space test currently lives 14.5 billion miles from Earth, requiring almost 2 days for the transmission and gathering of messages. NASA architects never guessed that Explorer 1 would proceed with its space investigation for almost 50 years. In 2013, Explorer 1 distinguished 500 unidentified objects going through space, starting huge conversations. Widely popular podcaster Joe Rogan joined the discussion to reveal insight into the disturbing ramifications of this exceptional disclosure. These baffling items could be crafted by extraterrestrial creatures or a breakdown on the shuttle. The Catch-22 has enthralled researchers for quite a long time. However, the new, uncommon experience in profound space has sent shockwaves through mainstream researchers, possibly revealing insight into the age-old inquiry of the presence of outsiders. Joe Rogan, an unmistakable observer and web recording host known for his sharp interest in examining outsiders and the probability of cutting-edge developments, has previously facilitated visitors such as David Grush and ABY Curve to investigate the potential for life beyond Earth. The weighty Explorer 1 mission was considered during the 1970s when NASA researchers had the opportunity to actually handle the size of our vast neighborhood. Everything began with an incidental arrangement of Jupiter, Saturn, Uranus, and Neptune, the 4 biggest planets in our planetary group. A youthful PhD understudy named Gary Flandreau found a striking divine peculiarity that would redirect space investigation in the last part of the 1970s and early 1980s. The 4 planets adjusted in an entrancing arrangement, looking like pearls on an inestimable jewelry, with Earth settled among them. This disclosure sent swells of fervor through NASA, as it introduced an extraordinary valuable chance to advance the direction of a space test by keenly using the gravitational draw of every planet during flybys. Flandreau assessed that these gravity helps from the giant planets could recoil the flight time among Earth and Neptune from 30 years to 12 years. Anyway, this heavenly arrangement happened just once every 176 years, so NASA set out on an aggressive mission to gain by this once-in-a-lifetime opportunity. Explorer 1 and Explorer 2 were twin rockets sent off in 1977 to investigate the secrets of the planetary group. Experience into interstellar space was sent off 15 days apart. They became vital pieces of NASA's Explorer space program, a testament to mankind's unquenchable interest and journey for knowledge. For almost 50 years, Explorer 1 has been radiating back significant information to Earth through NASA's deep space network, overcoming any issues between our earthly presence and the secrets that lie beyond. Explorer 1's unprecedented excursion is as stunning as it is arranged 24 billion kilometers away from Earth, making it the farthest man-made object from our planet. The space test was meticulously planned and built by NASA's Flight Drive Research Facility and left on its memorable odyssey from Launch Complex 41 at the Cape Canaveral Air Force Station, pushed by a Titan IIIe launch vehicle. One vital mystery to Explorer 1's launch is the presence of double XS computer systems. Both Explorer 1 and its twin, Explorer 2, were prepared with 2 arrangements of command computer subsystems, flight data subsystems, FDS, and attitude and articulation control subsystems, ACS. This overt repetitiveness guaranteed smooth changes among frameworks and the capacity to enact lethargic computer parts when required, effectively expanding their life expectancy. The computer systems on board Explorer spacecraft were organized as a distributed system with 3 double XS sets of computers, guaranteeing that regardless of whether one system fizzled, the other could flawlessly take over, preventing crucial failures. Power management is a crucial component for maintaining the operational integrity of Explorer 1, as the rocket's distance from the Sun, where it can harness solar energy, represents a significant challenge. Specialists needed to think of creative ways to ration and improve power utilization, such as exceptional specific power shutdowns of unnecessary systems. In summary, Explorer 1 and Explorer 2 have been instrumental in revealing the secrets of the nearby planetary group and interstellar space, providing pivotal insights into the vastness of space and the secrets that lie beyond our understanding. Explorer 1 is a space explorer that has resisted all assumptions, sending back important data close to 50 years later. Its launch was initially intended to endure just 5 years. Explorer 1 has been prepared with a noteworthy, gigantic array of scientific instruments, suites, and subsystems. These instruments were decisively placed on the shuttle's body, which comprised of a staggering 65,000 individual parts. One of the persisting instruments on both Explorer 1 and Explorer 2 is the low-energy charged particle detector. This instrument boasts 3 arrangements of particle sensors that measure the quantity of low-energy particles that strike it, as well as their speed. It determinately notices cosmic radiation and particles originating from the Sun, planets, and interstellar space. A sidekick instrument, the cosmic ray instrument, effectively searches out highly energetic particles from both the Sun and other cosmic sources. The plasma wave subsystem, including 2 elongated radio antennas situated at right angles to each other, serves as a fundamental tool for measuring the electrical field components of possible waves experienced at the outer planets. However, its role has evolved as the explorers have wandered into interstellar space over the years. Architects have made momentous technical advancements and enhancements in power management strategies, including more efficient power distribution, improved battery charging techniques, and progressions in power regulation and control. Explorer 1 continues to send back significant data, exhibiting the devotion and expertise of the researchers and designers who have worked indefatigably to keep it functional. The Explorer tests, initially intended to research the magnetic fields of outer planets, have been undergoing massive changes as they progress into interstellar space. The magnetometer, initially intended to concentrate on the magnetic fields of outer planets, now assumes a crucial role in investigating the transition region between interplanetary and interstellar media. This instrument is utilized to investigate the magnetic properties of the transition region at the boundary where the Sun's magnetic influence intersects and gives way to the magnetic field of interstellar space. The plasma science instrument, which analyzes the least energy particles inside the plasma, is now functional only on Explorer 2. This instrument is a testament to the continuous scientific investigation. NASA has deliberately deactivated heaters on both spacecraft following 21 years of activity, and unnecessary instruments have been permanently switched off. The power source for each rocket is 3 radioisotope thermoelectric generators, RTGs, which utilize the heat generated by the radioactive decay of plutonium-238 to produce power. As plutonium-238 continues to decay, it will eventually no longer be able to provide power, leading to the discontinuation of all instruments around 2025. To draw out the functional life expectancy of both rockets until 2027, the Explorer team is using careful power management strategies. Each test is equipped with engines for maintaining communication with Earth, and the main transmitter emits approximately 20 watts of power. However, the strength of the signal from Explorer reaches Earth is 20 billion times more vulnerable than that of a digital watch battery. Explorer 1's journey through space has not only expanded our understanding of the nearby planetary group, but has also provided crucial insights into the nature of the Heliosphere, the bubble of charged particles surrounding the Sun. As Explorer 1 moved further from the Sun, it began to experience different environmental conditions than those experienced by prior spacecraft. Quite possibly, one of its most significant contributions has been its role in mapping the structure of the heliosphere and its boundary, known as the heliopause. This boundary marks the transition between the solar wind and the interstellar medium, where the influence of the Sun diminishes and the material from other stars begins to dominate. By sending back information from its plasma wave instrument, Explorer 1 has assisted scientists in better understanding the behavior of plasma in this transitional zone. This data is critical for understanding how cosmic rays from outside the solar system interact with the heliosphere and how these interactions influence space weather. Such insights are fundamental not only for astronomy but also for protecting future spacecraft and astronauts from hazardous space radiation. Another surprising aspect of Explorer 1's mission is its contribution to the study of magnetic fields. As Explorer 1 crossed the boundary into interstellar space, it provided the first direct measurements of the magnetic field beyond the solar influence. These measurements have been crucial in enhancing our understanding of the magnetic environment of the interstellar medium. The data gathered assists researchers in modeling the magnetic interactions between various regions of space and understanding how these connections influence vast phenomena. Explorer 1's longevity and continued data transmission have also led to an improved understanding of the elements of cosmic dust. The spacecraft's dust detector has been instrumental in measuring the density and speed of interstellar dust particles. These measurements provide valuable data on the composition and distribution of dust in our galaxy, which in turn influences theories about star formation and the evolution of the interstellar medium. The spacecraft's ongoing mission has also shed light on the development of technology used in space exploration. The engineering achievements accomplished by Explorer 1's mission have set a precedent for future deep space missions. The creative design and resilience of Explorer 1's systems have influenced the development of subsequent spacecraft, demonstrating how engineering solutions can extend the life and effectiveness of space missions far beyond initial expectations. In addition to its scientific accomplishments, Explorer 1 carries with it a symbolic message to any potential extraterrestrial civilizations. The Golden Record, containing sounds and images chosen to represent the diversity of life and culture on Earth, serves as a universal greeting and a demonstration of humanity's desire to connect and share its presence with the universe. This message, alongside the spacecraft's data, represents a significant milestone in mankind's quest to explore the cosmos and engage with other intelligent beings. Taking everything into account, the Explorer tests have made significant strides in their investigation of interstellar space and the secrets surrounding the discovery of 500 unidentified objects. Explorer 1, a space test, has found 500 obscure objects in the depths of space, igniting a flood of concern among specialists. The initial data communicated back to Earth was turbulent and resembled a distorted message from the universe. NASA's Flight Impetus Lab was flabbergasted by the disarray and found that the Attitude, Explanation, and Control System, AAC, had switched to utilizing a defective onboard computer that had been dormant for quite a while. This led to distorted telemetry data. NASA specialists swiftly resolved this issue by reconfiguring the AACs to send data through the right computer. Uncorrupted data from Explorer 1 is now streaming again. The inquiry remains: what incited the AACs to use the failing computer? In any case, NASA researchers have yet to provide a conclusive answer, but have proposed a theory suggesting that the AACs received a wrong order from another onboard computer. Suzanne Dodd, project manager for the Explorer Interstellar mission, revealed that a complete memory readout of the AACs will be conducted, followed by a thorough examination of its operations to analyze the underlying cause of the telemetry issue. Several factors could contribute to the peculiarity, including the ambient conditions of space, cosmic radiation, emotional temperature changes, and exposure to micrometeoroids like dust particles and fragments from asteroids and comets. As Explorer 1 endeavors into interstellar space, its plasma wave instruments have reliably detected the effects of dust particles due to their high radial speed. When a dust particle crashes into a spacecraft, it quickly disintegrates and ionizes, producing a growing plasma cloud that triggers a voltage pulse in the electric antenna of the plasma wave system. While various hypotheses have been advanced to explain the misfire in Explorer 1's system, one possibility that captures the imagination and belongs in the realm of sci-fi is the involvement of extraterrestrial beings. However, this hypothesis is highly speculative and not widely accepted in the scientific community. The concept of intelligent extraterrestrial life has fascinated researchers and space enthusiasts alike. Joe Rogan, a famous podcaster and media personality, has explored this topic through discussions with analysts and UFO enthusiasts, particularly David Grush, a former Air Force intelligence officer and representative of the Public Observation Office to the Unidentified Flying Phenomena team. These conversations have added fuel to the interest surrounding Explorer 1's breakdown. Joe believes that the universe is vast, with billions of galaxies, stars, and possibly even more planets. The possibility of intelligent civilizations elsewhere in the universe raises exciting inquiries about their potential communications with Earthlings. If these extraterrestrial beings inadvertently found Explorer 1, they could have seen our spacecraft as it navigated the universe and chosen to explore it out of curiosity. This scenario suggests that the error could be their way of sending a cosmic message, a form of interstellar hello. The Golden Record, an extraordinary relic on board Explorer 1, serves as an interstellar time capsule intended for any intelligent life that could come across it. If extraterrestrial beings managed to access the Golden Record, they would interpret an abundance of information about Earth's societies, languages, and the astounding variety of life on our planet. This raises significant questions about how they would interpret our music, art, and what they could make of our languages and scientific knowledge.